All right. Happy St. Patrick's Day, and can you find the can you find the leprechaun with the pot of gold? I don't know. I wish I could. Unfortunately, we're going to talk about the lesson 2.1, the task. This stuff is kind of the heart and soul, if you've missed part of this, of Math 2. We're going to begin looking at quadratic functions, and we start off with how do things change a little bit. So I'm going to kind of be in the picture and out of the picture a little bit using Desmos a little bit, just so we can kind of figure out what's going on. If you weren't in class the other day, we did page 3 here as a warm-up. Just we went back and revisited the patterns. I'm not going to talk about that in this video. All right, I'm going to go straight to the lesson, and in the lesson we're going to talk about what happens to the graph of y equals x squared, or f of x equals x squared. What happens with that when we do certain things. And the vocabulary that we're going to see is we're going to see a horizontal shift, so they will shift right or left, that's horizontal. Line of symmetry, we'll talk about what that is. Parabola, you should know, that's a U-shaped graph. We're going to talk about reflections. If you remember last semester, we talked a little bit about reflections. Okay, actually we talked a lot about reflections. Symmetry, okay, so symmetry and line of symmetry, those are the same. Transformations, how do parabolas transform, rigid, non-rigid. We're going to talk about the vertex. We're going to talk about a vertical shift, which is up and down. And we're also going to talk about a vertical stretch, right? And I'll talk about what that is. We started off yesterday, and there's a little bit of a change in this book. We started off the other day by talking about what happens with a line when we add 3, when we subtract 3, and this little bit of change right here should be y equals x minus 3. And what happens if we change the slope? Well, basically what happens, let's graph. We graphed y equals x. They graphed that for us. So now we're going to graph y equals x plus 3. We'll think of y equals mx plus b. M is 1, b is 3. So we go up to 3, 1, 2, 3. We're going to rise 1, run 1. There's my line. What happened? It shifted up 5 units. Make sure you make a note of that, okay? It shifted up 5 units. What happens then if we subtract 3? Well, if we subtract 3, you should note that it shifts down 3 units. Pretty simple. Shifts up, shifts down. So the change in the b value causes my line to shift up and down. What about if I change my m, or my rate of change, 3? What happens? Well, this is plus 0. My y-intercept is 0, and I'll do a third color here, one that hopefully we can see. My third color, it's going to cross at 0, so it crosses the same as my original line, but this time I rise 3 and I run 1 and connect the dots. What has happened, instead of the line shifting up and down, the slope of the line has changed. That's what M does. B just causes a shift up and down. M causes a change in slope. Why are we going back and revisiting this? Well, we're going back and revisiting this, one, because most of us don't remember what that does, and second, we're setting the stage for what happens when we add 5 and then square. What happens if we square and then multiply by 5? What happens if we multiply by 5 and square, or we square and add 5? What happens to my diagram? These things change a little bit. And that brings us to the next step here. What I want you to do is I want you, you could put some blanks right here. That's kind of what we did in class. I want you to pause and see if you can match A, B, C, and D over here with its correct number. So go ahead and pause this and give it a shot. See how you do. It says the length of each side is increased by 5 units. I'm going to take the length. Remember, go back, our original square right here, x by x. Okay? I'm going to take each side and I'm going to add 5. And then I still have to find the length times the width. Well, the length is now x plus 5. The width is now x plus 5. And how else could I write this? X plus 5 squared. So there's A is 2. The length of each side is multiplied by 5 units. So I'm multiplying each side by 5 units. Then I'm finding the area. That should be 3. The area of a square. I'm finding the area of a square. So go back. I need to get rid of this. Get rid of the plus 5s. We find the area of a square first. Well, gee, that's x squared, right? X by x is x squared. And then it's increased by 5. What function does increase mean? Increase is plus, so this should be x squared plus 5. There is C. And then obviously the default one, number 1 is D. The area of a square, again, the area of a square is multiplied by 5. So I'm taking the area of a square and I'm multiplying it by 5. Done. All right, number 3. What do we notice down here in number 3? I had issues with this yesterday. Optimist stated that she's going to graph y equals x and kind of do a little compare and contrast here. Well, what do we notice about what's going on? All we're doing is comparing the table with the graph, right? So just what features do you notice? How do we notice that this is a quadratic function, because this table matches this graph, without doing first and second differences? Well, what you should notice is 9, 4, 1, 0, 1, 4, 9. In other words, we meet in the middle. All right? So if we meet in the middle, what do we notice? Some key features here. 1, 4, 9. You should notice that pattern. Okay? Over 1, up 1. Over 2, up 4. So there's 1, 4. Over 3, up 9. Right? Over 1, up 1. Over 2, up 4. Over 3, up 9. That pattern, we'll see that pattern a lot. We'll see another one as well, but we'll see that one a lot. Some other key features. Yes, it's a parabola. Yes, it's opening up. My vertex is at 0, 0. It's also a minimum, min. Okay, so it has a minimum value. My y intercept is 0, 0. My x intercept is 0, 0. All right? Some other key notables, and I'm just kind of drawing a blank right now. We're just comparing. I don't have my notes in front of me. I don't want to go get them. Yeah, I'm going to be lazy. That's pretty much kind of it right there. Oh, one other thing. Axis of symmetry. And I label this A, capital A, lowercase o, S. What is my axis of symmetry? It wants me to draw that. The axis of symmetry divides this parabola in half. They become reflections of each other. All right? The axis of symmetry is always going to be x equals something. In this case, it's always x equals 0. All right? So the axis of symmetry is x equals 0. That was one other feature. All right? And then we move on. All right? So let's see what happens when we begin using a Desmos calculator. Title your activity transformations investigations 1, then save. I'm not asking you to save your Desmos here. Using the calculator, begin by graphing y equals x squared. All right, so I'm going to go through. I'm not going to do all these, but I'm going to show you how to do them. Right? So we're going to go to the Desmos graphing calculator, and you're simply going to graph y equals x squared. So I'm going to put this up on the board here. All right, and you're going to graph y equals x squared. Now the first one they want you to look at is y equals x squared plus 5. Okay? So what is the similarity of y equals x plus 5 to the differences of y equals x squared? Well, here's y equals x squared, and if you need to, do y equals x. Now in order to get the square, you have to hit shift 6. It gives you a little caret up there, and you'll do square. Notice it covered the other one. Tab over or space over to the right, and then you're going to hit plus. You'll figure out how to do that. And then when you hit plus 5, see what happens. So what happened to it? Well, hey, it shifted up 5 units. Yeah, it didn't get wider, it didn't get narrower, it didn't do anything. All this original parabola did was shift up 5 units. Okay, so how is it similar? How is it different? Well, think, it's still a parabola. Right? It still has a pattern. It didn't stretch. It didn't shrink. All that happened was it shifted up. The vertex moved up 5 units. If I put x squared plus 5, It just shifted up 5 units. Like, hey, what did the B value do? The B, it's kind of like the B value in what we said. It shifted the line up 3 units. In this case, it shifted it up 5 units. Right? So talk about the similarities and differences there for all of those. What happened in that section? Right? What happened in that entire section? Okay? What happens if it's x plus 5 and then I squared? What are the similarities and differences? Right? And then when you get to 5, what happens when you get to question 5? So we're going to go through, when we get to question 5, somebody really wants to get a hold of me. Using what you learned at Desmos Calculator, describe each of the transformations. So you should be able to get to 5 and describe these transformations. Okay? So looking at this, I'm going to say the parabola shifts up 2 units. Because I don't know what those units are. Okay? B, C, D. Use Desmos if you have to. If you don't understand what it does when there's parentheses here or when there's a negative there, right? Put it in there and then describe what it's doing. The parabola is just shifting. That's all it's doing. All right? So you need to complete that. And then on the back page, there's a takeaway stuff. It talks about ready for more, equation, transformations. Okay? So what it's getting you to do here is it's saying the transformations of y equal x squared. What does k do? It's getting you to recognize, well, gee, k causes this to shift up or down. H, what does h do? H shifts it right or left. So a minus h would cause it to shift to the right. A plus h would shift it to the left. I gave you most of that information. Right? So work on that, get that done. If you got questions, ask me.